everybody. So I am André Brandão. I will present this work here. Jecripe, how a serious game project encouraged studies in different computer science areas. So I made my PhD here in this university, in Fernandes University. I was supervised by Professor Esteban, who is sitting right there. And when I submitted this work, I was associated to this university, but nowadays I am associated with another university in São Paulo State. It's a bit funny to say the name of the university in English, because it is ABC Federal University, because it is related to 3 cities in the metropolitan region of São Paulo. St. Andrew, St. Bernard, St. Caetano, so ABC, so it's in that region. So, let's continue here. The summary of this presentation, I will talk about the Jecripe Project, just a little bit about it. The first game of the project, the Jecripe game, and then I will talk about each of the computer science areas that this project is associated, and then I will go to the final considerations. So, first of all, the Jecripe Project. So the Jecripe Project is a project that I started in 2009 here in Niterói, and which the main goal of this project is to develop games for people with special needs. So it was an acronym for a game for stimulus for children with Down syndrome. Okay? So in preschooler age, so between 3 and 7 years old. But now, this acronym is different because it motivated me to continue further more and continue to develop more games of this kind of people. So nowadays the acronym is games for stimulus created for special people with special needs. So about the first game, is the Jecripe game. The game was created during the year of 2009, and it was launched in 2010, so 2010. And we had to choose different cognitive abilities to be stimulated during the game. So we chose imitation, perception, fine motor skills, and hand-eye coordination. And each of these cognitive abilities motivated us to develop a different virtual environment. So for imitation, we developed the music house. For perception, we developed the bubble house, and for fine motor skills, we developed the daycare center. So something new about this game is our characters, our 2 characters, they have Down syndrome. Okay, so this is something unusual, and for as long as I know, it was the first 2 characters with Down syndrome in digital games. About the environments, so the game has an island with the 3 environments. This is the bubble house for perception stimulation, and there are some bubbles with toys inside each of them, and according to each color, the player have to put the toy in the right box according to the color. So this is a kind of stimulation. The user has to use the mouse, so only moving the mouse without clicking. And so there are 3 stages in this activity. The second house is the music house, where the player has to imitate some movements, some dancing movements of the character. This is Betinho, the main character of the game. And this activity inspired my PhD thesis, which I'm going to talk more about it. And the last environment is the daycare center, where the player has to make a drag and drop movements according to each object of the game. So the characteristics of this game, some cognitive abilities inspired some activities developed in the game. There is a suggested progression. So the first activity, the player do not click the mouse. He or she only moves the mouse. And then the second one is the dancing movements activity. And the last, the drag and drop activity. The mouse pointer has the features of a hand of a child with Down syndrome, and the characters also have physical features of children with Down syndrome. So the main goal of this was to make an identification of the person with Down syndrome, the player with Down syndrome, and with the family, friends that are associated with the player. So about the project in different computer science areas. So the first area I'm going to speak about it is computer vision. So this was the main contribution of my PhD thesis, and I will talk a little fast about this. So there is many stages to make the M5 AIE method, and this is a method for body part identification, labeling, and pose recognition. So the first stage, there is the RGB TR Alignment, where the color and depth information are aligned, and then we make a background subtraction, because there is an amount of information that are unnecessary to make the pose recognition. And then to reduce even more the information, we use the medial axis transform. After that, we find the agex points detection, make the main agex points detection, which are each of the extreme points of the body, the hands, the feet, and the head. After that, there is a starting configuration where the user has to make a T-pose, something like this. So in this pose, the upper body parts are, how can I say it, is over the medial point, and the feet are under the medial point. So until this configuration stands, we can label each of the body parts, and then we can generate a tuple for a classifier, and this classifier is going to give us the user pose. If this starting configuration is not does not stands, so we have to track each of the body parts using a tracking method, where we use the ASIFT algorithm. And the ASIFT algorithm for people from the computer vision area is an improvement of the SIFT algorithm. Okay, so the RGB TR alignment. So in our left side we have the image only with depth information. On our right side, at the same time these two images were captured. Only the RGB information here. So we can see a lot of amount of information here that are unnecessary for the pose classification. So we align, but sometimes we use the Kinect SDK to align these two information, and sometimes there is a problem when the points. When the movements are made very fast, some points are painted with wrong colors. So we have to handle that. So about after the alignment, we were able to make the background subtraction, and these small red points are the extreme points. But we observed that still we could reduce even more the amount of information. So then we applied the medial axis transform. Then it was much less information to handle with, and then we could make the Ajax points detection more easily. So, after these stages, in the end, we have a classifier that has as input plenty of tuples, and each tuple is associated to frames, okay? And these frames and these tuples will be used for a classifier, and this classifier will give us the user points, the user pose. So this is the moment that I will talk about data mining in the Jecripe project. Okay, so the classifier, it has as input plenty of tuples. Okay, and then this classifier data with plenty of tuples will have a classifier data training, and with this classifier data training will be used to build the classifier model. And this classifier model will have as an input a testing tuple, and as an output a testing tuple with a predicted class. So we made some experiments, and we divided the image in cells. Okay, so instead of using image coordinations, we used the cells. So the cells are described, the position of each body part are described with the row and the column of the position of where the body part is located at each moment. And this is an example of 8 by 8 cells, but we tested also with 16 by 16 cells, 32 by 32, and 64 by 64 cells. So we compared 3 very well-known classifiers: the decision tree classifier, the naive Bayes classifier, and the KNN classifier, the key nearest neighbor, and the winning algorithm. This is how can I say this? These are results described in another work, so I'm not going to give so many details right now. But the winning algorithm in our experiments was the KNN algorithm. Okay, so the last computer science area was the human-computer interaction, and we made semiotic inspection in our game. Semiotic inspection is a method from the semiotic engineering method, and it is used to evaluate applications. So it could be used for application in general, but we apply it in a game. And there is no use of so the user is not present here, but we, how can I say, we recorded some videos with one user using the game. So about the music house, we observed that the musics were very complex and the movements were also very complex. So the user had some difficulties on making these movements. The bubble house, the observant user already knew how the mouse works, so she was clicking all the time without any need. And the daycare center, because of the knowledge of the user, of the experience of the user could easily use this activity and finish this activity. So final considerations. We presented the Jecripe game, the Jecripe project, and with the first game developed with 3 different activities. The Jecripe project inspired more studies in different computer science areas, such as computer vision, data mining, and human-computer interaction. And I have some ongoing research in human-computer interaction, where I'm making some studies to help to indicate a method to create ludic games for all. So for all, I mean the use of universal design, so design for all people, participatory design, where the developers are with the users, and when they develop application, and they do not develop applications for the users only. Game design, I think it is important to include studies in computer science about game design concepts. And I intend to use the natural user interface in the next games for the Jecripe project. So this is my contact. The Jecripe game is available in 5 different languages, in Portuguese, Spanish, English, German, and Turkish. And it is available for Windows and Mac platforms. And if you have any doubts or if you want to contact me, this is my email. Thank you very much.